Hello, good morning from Berkeley, California, where I'm pre-recording this talk. I'm going to be talking today about XJSLT, which is an XSLT compiler for JavaScript. My name is Erik Hetzner. I work at the Public Library of Science, which is a nonprofit open access publisher, science publisher, mostly in the biosciences. And we publish like 10 journals across a number of fields, and we use XML and XSLT pretty extensively, especially JATS, the JATS version of XML for all our articles. And I should add, though, that this work is totally unrelated to my day job, and it's purely something that I did on the lark for fun. I'm really happy to be presenting it today to you all at Declarative Amsterdam. Sorry I can't be there today. Really would have liked to. But I'm really looking forward to the Q&A session. I'm really looking forward to some of the other sessions, seeing them, meeting people virtually. And so, yeah, thank you especially to the Declarative Amsterdam organizers for inviting me. Again, I'm really looking forward to this. So let's get started. Just to outline of what I'm going to be talking about today. I'll give you a brief introduction, let you know what is missing and what is next, explain to you what it means to compile XSLT to JavaScript, give you a little bit of insight into some of the optimization that I've done and some of the future optimization I hope to do, and then an interesting little trick with XSLT compilation that it allows, which I've noticed, and that's it. And then Q&A. So let me give a brief introduction. Just the name XJSLT doesn't stand for anything. It's just XSLT plus JS. I thought it sounded good. It is a little hard to pronounce, so I'm probably going to stumble over the words a bit. XJSLT compiles XSLT directly to JavaScript that can be executed directly in the browser or in Node.js. So it creates executable JavaScript files that can be called. Why did we do that? Did I do this? I thought it'd be possible. It just seemed fun. I kind of did it on a lark, and I was curious to see how far this could go. And it's gone a lot further than I expected, and I'm curious to see how far it does go from here. And I think the world also needs another XSLT2 implementation. A lot of people are not fans, particularly of XSLT. A lot of people at this conference probably are. So I don't need to defend it. I think it's basically the best thing we have for XML transformations, obviously. And I think it would be nice to have more than one main implementation available. So I'm excited to be able to add that. But what is missing at this point? It's incomplete, it's slow, and it only passes about half of the XSLT test suite. But the XSLT test suite is really comprehensive. It includes a lot of edge cases and bugs. And so don't let that dissuade you. It is substantially more complete than any other open source XSLT2 implementation besides Saxon that I'm aware of. There's only a few sort of top level features missing at this point: XSL number, attribute set, and analyze string. Number and attribute set I just haven't implemented yet. Number is tricky. Attribute set doesn't seem to be that widely used, so I haven't done it. Analyze string depends on some upstream work, so either I need to file a pull request for that, a fix for that, or wait for some upstream work for capturing. For regex capturing. Good error reporting still needs work, but as you'll see, there's a real path forward with that. And lots of edge cases. Whitespace and namespaces are tricky, and there's some bugs or improper implementation of some of the algorithms for output in XJSLT at the moment. So what do I want to work on next on this? I think speedups are sort of my primary concern. I think I'd just love to see better speed from this. Also, that's more fun to work on. Fixing edge cases, it's a little boring to work on, but sort of essential. And then whatever others can help with, of course. I'm pretty busy with a 2-month-old at home, so I haven't had a lot of time to work on this for the past couple months, as you can imagine. So if you Google XJSLT, you'll find the GitHub. I've linked to them here, but those are, you can get the code there. You can file merge requests or pull requests. You can file issues. I'm really curious to see how it works for all you. So I'd like to talk about compilation a bit. First off, I'd just like to say off the bat, I did kind of think compiling to JavaScript directly would be fast. I don't think at the end of the day it's really faster than compiling to some intermediary format like Saxon does. But it is actually reasonably easy to do in JavaScript / TypeScript, and it means you can create simple redistributable files. So I'm happy with the process in general. I think it's reasonably simple, and it has some interesting benefits, which I can go into later. So as an example of how this to compile JavaScript files are used, in this example used in the browser, transform.js is a file that's been created by XJSLT, and that is an output file basically from XJSLT. And you can see here we're loading it directly. We're parsing an XML string using the DOM parser, and then we're getting an output node in the browser's DOM, and then we're calling directly the transform function, which is exported from transform.js. And that will take the DOM, the parsed DOM, transform it according to the XSLT transform, and then output it directly into the browser DOM. This is just an example of what the XSL compilation process looks like. This is a very simple template. You can see we've got a header. It's matching a header element in an XML file, and it's outputting an H1 HTML element, and then whatever the apply templates to the child nodes of the header. That's a typical transform that we see all the time, and what this is outputted to in the JavaScript, you can see, is a JavaScript object here with some metadata. Include metadata like the match pattern, the modes, in this case it's just using the default, etc. What's interesting here is there is a function here that takes a context variable. That context stores the dynamic context of the transform, like what node we're at, etc. in the input. And then there's actually a function here which calls out to some XJSLT helper functions. In this case, literal element, which outputs a literal element, H1 literal element, and passes in the dynamic context to that. And then another of the arguments to this literal element helper function is another function which again takes a context, dynamic context variable, and then calls out to apply templates. So going back briefly, basically the control flow that we're looking at here is we call out to the transform function, and that starts the process on the root node, and that's a compiled function. And then we determine the template to use for the node, and that's transform uses XJSLT's internal helper functions to determine which template is to be used for that root node. And then control is passed to the compiled template, and then that compiled template calls XJSLT helper functions, for example, literal element, as we saw in that example. And then the compiled template returns flow either by returning from a function or by calling apply templates or similar, like for each helper functions, which determine what template then gets applied to a given node. That's very high level. I hope that made sense. I can go into it more in Q&A perhaps, and obviously you can look at the code to see how it works. But basically, control is passing back and forth between compiled code and XJSLT helper functions. So that's that. That's how the compilation process kind of works. Right now, we use I'm going to talk about speed and optimization. Right now, we're using a very naive method that checks each possible template in turn, looking for matching patterns. So what pattern matches and what template we should use for this given node that we're looking at processing. If you read Saxon design docs, this will be, I think, dismissed as a very naive method that wouldn't work well, and it doesn't work great. It's a little slow. But we do a few speed ups right now. We cache XPath results. So when we call an XPath on a given node, with a given node context, I should say, we cache those results, which means it's a little faster than would be otherwise. We also have what I call some fast failure or fast success to bypass full XPath processing when we're looking at a given template pattern and a given node. So for example, if we're looking at the pattern text, and that we know that that's only will only match a text node. So we can, any other type of node, we can quickly just say that is not a match. And if it is a text node, we can quickly say that is a match without calling out to full XPath processing. And as another example, like foo would only match, the pattern foo would only match an element with the name foo and no other element. In the future, I'd like to expand that sort of thing, having now read the design docs for Saxon, to move to a decision tree as Saxon uses to determine which template to use for those simple patterns. I think that would be a huge speed up. I'm really excited about getting the chance to implement that. So I'd like to discuss now something that arises when you're compiling XSLT to JavaScript. One of the side benefits of that compilation process, as well as XSLT's unique situation as an XML-based language. And so just to indicate how that works, show you how that works. What we have here, you have basically the kind of very basic XSLT code that most programmers, when they first see it, who are not familiar, think this is incredibly verbose and crazy. Why would you do something so complicated? Why would you have it in this format? And why not just make it look something like Python? And that's not entirely wrong, but having it already in a sort of XML-based format means that it's ready to be transformed by itself. So in this case, you can see you have a transform that will take our previous code and will match the parameters here, and then output a parameter with the same name equals prefix here, and hello world as the text for that parameter. And that is very useful, basically, because we can take this code, or this would be the output, I should say, of that code, of taking that XSLT and then passing it into the second XSLT, outputting more XSLT with slightly changed parameters. Basically got a snake eating its tail. XSLT taking XSLT, outputting XSLT. And what this is useful for when you have a compiler is that you can compile that XSLT that we first saw down into JavaScript and then incorporate it as part of the JavaScript compilation process itself. So for instance, the first rule in XSLT whitespace stripping is to remove all the comments and processing instructions. So if you have an identity transform of XSLT, an XSLT identity transform, and then you add this little template that we see at the bottom there, which matches either comment or processing instruction, and outputs nothing, you've implemented part of that process. Another example that I've been using this for is static error analysis. So if we assume another XSLT identity transform, and then we include this little template, which would match an XSL variable or XSL with param element. And the rule with those elements is that it can either include a select attribute or it can include children, either like node or text. So it can include one or the other here. And if it includes both, if this and is true, then we can do an XSL message, terminate the process, and output this error message, XS or XTS E0620, and then the message variable or parameter, and then we include the name, has both at select and children, which is what we don't want. And then if it doesn't match, then we just move on to the next match, which is the identity transform. So if you include this little piece in the compilation pipeline, then it will perform this error message or perform this error handling, which is a very easy way to implement error handling as compared to writing custom JavaScript to navigate a tree and find certain things. XSLT, of course, is a great language for doing that kind of massaging of XML and matching XML. That's what it's for. So it's amazing to be able to use that in our compilation process itself. So this technique is currently used to handle includes and imports, error handling, some white space stripping, and I'd like to use it to implement even more functionality. I think it would be possible to implement attribute set using this. So that's the end of the presentation, but before I finish up, I just wanted to thank the authors of fontoxpath, Steph Busking and Martin Medell. I hope I'm pronouncing your names correctly, and any others. This is the TypeScript XPath 3.0 implementation, which makes this whole thing possible. And likewise, the authors of the XSLT test suite, Michael Kay and Debbie Lockett, and that test suite as well. Without that, it would have been impossible to implement all of the features that I've done and to fix the bugs and just have a comprehensive sense of how close I've gotten to the correct implementation. So thank you all very much. Looking forward to your Q&A.
I'll repeat my question. We already got your answer, but I'll repeat the question. Do you have any plans for XSLT 3 instead of calling this an XSLT 2? You already answered, and we did hear you, but the room didn't.
Oh, sure. Yeah. Let me answer that again. Yeah, I would love to do that. I think I haven't done an analysis of what would be feasible to implement in XSLT3 and what is required by the spec. So for instance, I'm told that streaming is an optional thing, and I don't think that's a feasible thing to really implement given the existing underlying implementation, which is based on DOM parsing. So I don't think streaming would work with that. But I haven't really looked into it, and I don't know what other features are reasonably easy or not reasonably easy, but feasible to implement, given the existing structure of the implementation. I hope you could hear that.
Yeah, we heard fine. Can you hear me?
Yes, perfectly. Thank
What
you.
time is it with you?
It is 5:30 a.m.
Thank you. Anybody else have a question? Nobody? Well, get some sleep if you can. Sid Bauman has a question. Sid.
Thank you for the presentation. I hope I can be heard without too much echo. I'm curious. I guess there are two things poking at me. The first is just a broad picture of how much time have you put into this, and perhaps you don't want to admit that to yourself. I don't know. And second, how much of that time is spent working on handling XPath itself, and how much is working on the XSLT structure around XPath, which is sort of the same question as how much time would it take to do XQuery instead?
That's a very good question. I don't think I conveyed enough my thanks to Fonto XPath in the thank you because I've spent zero time working on XPath, and that's thanks to the existing implementation from fontoxpath. In terms of how much time, yes, I don't want to admit it to myself, but it is a side project. I mean, in the 100-hour range, I guess. Once it kind of came together, each little piece of each XSLT, instruction is not that much code, once you transform it into JavaScript, if it's an if statement or whatever, if you assume there's an XPath implementation existing. But the entire structure of it, has been a bit of work. And, like I said, just handling all the little edge cases have been a lot of work figuring out, which errors are broke or which tests are erroring, and then circling back and more carefully reading the spec and realizing what I did completely wrong.
I mean, I won't be surprised if you find that the tail end of fixing errors takes up much more time than you have so far.
Yeah.
But good luck. This is fantastic.
Thank you.
One more question from Yuri Lino. Can you hear me?
Yes.
Oh, so you said it's not so fast, but what is, like, can you give us at least a feeling for how fast is it or how slow?
Yeah, I mean, I think I test often using a pretty substantial, reasonably substantial XSLT style sheet that transforms JATS XML files into HTML. And Saxon JS will compile and then run that. Actually, I don't remember exactly what the data is for compiling and then running the compiled file. But it's sub-second running the compiled file, sub 1 second, probably for 300 milliseconds or something. And what running the compiled file for XJSLT will take about 4 seconds. And I'm very hopeful about the decision tree path. I think that will really increase that speed, because when you do an analysis sorry, it is 5 in the morning. When you do it, looking at the at how long it takes instrumentation, it takes like most of the time is spent in XPath processing. So obviously, whatever we can do to reduce that XPath processing will lead to substantial speedups.
Okay, once more, thank you, Erik.
Thank you so much.